Imagine having no refrigerator, no freezer, and no electricity to preserve your food. Yet ancient people could preserve meat, fish, grains, fruits, and vegetables for months. They did not have one universal method, they used several preservation techniques. The key was controlling moisture, temperature, oxygen, salt, smoke, or acidity. The first enemy was surprisingly simple: water inside the food. Microorganisms need available water to grow and spoil many foods. So one ancient solution was to remove water before microbes could multiply. Sun drying was one of humanity's oldest preservation strategies. People sliced foods into smaller pieces to increase exposed surface area. Warm air and sunlight then helped moisture escape from those surfaces. But drying was not always possible in humid or rainy environments. That is where another powerful ingredient became important: salt. Salt draws water away from food and makes microbial growth more difficult. Ancient communities used salting extensively for meat and fish preservation. Fish could be packed tightly with salt and stored in containers. Meat could receive similar treatment before being stored for later use. Another method used something people already had everywhere: fire. Smoking food exposed it to smoke while also helping dry its surface. Smoke also contains compounds that can help slow certain forms of spoilage. The result was food that could remain usable much longer. But ancient preservation went far beyond meat and fish. Grain was especially important because it could remain dry for long periods. Dry grain was stored in jars, baskets, granaries, and other containers. Keeping storage areas dry was essential for preventing mold and spoilage. Some storage designs deliberately reduced contact with damp ground. Ventilation could also help remove moisture from storage spaces. This reveals an important principle: preservation often began with architecture. The building itself became part of the preservation system. Cold storage provided another solution when suitable environments were available. Snow and ice could temporarily provide temperatures far below summer conditions. Some ancient societies developed dedicated icehouses for storing ice and food. These structures relied on insulation and shade rather than electrical cooling. The goal was not freezing everything permanently like a modern freezer. Instead, cold storage slowed processes that caused food to deteriorate. The same principle still matters in modern food preservation. Another fascinating technique involved fermentation rather than eliminating microorganisms completely. Fermentation changes food through controlled microbial activity and chemical reactions. Some fermentation processes create conditions that inhibit competing organisms. Salt could also be combined with fermentation for additional preservation. This combination appears in traditional preserved foods across many cultures. Preservation was therefore less about one invention and more about adaptation. Hot climates encouraged drying, salting, airflow, shade, and underground storage. Cold regions naturally offered freezing temperatures and seasonal ice. Coastal communities had abundant fish but faced rapid spoilage in warm weather. Salting, drying, and smoking transformed that short window into longer storage. This mattered because food availability was never guaranteed throughout the year. Harvest seasons could produce abundance followed by months of scarcity. Preservation allowed communities to move food from abundance toward scarcity. That made preservation a survival technology, not merely a cooking technique. It also changed how far people could travel with food. Dried foods were lighter because much of their water had been removed. Salted and dried foods could therefore become practical travel provisions. Military campaigns also required reliable food supplies far from harvest fields. Stored grains, salted foods, and dried provisions could support long journeys. But preservation always involved trade-offs between taste, texture, safety, and storage time. Drying changed texture, while salting could dramatically change flavor. Smoking added flavor while also contributing to preservation. Fermentation could transform the original food into something entirely different. So ancient preservation was also an early form of food engineering. People learned through observation which conditions kept food usable longer. Over generations, successful methods became traditions passed between communities. These traditions sometimes survived for thousands of years. What looks simple today often represents accumulated practical knowledge. There was no thermostat telling them the exact storage temperature. No electric fan measured airflow through a granary. No refrigerator automatically controlled the temperature around stored food. Instead, architecture, climate, materials, and careful preparation worked together. The impressive part was not defeating nature, but working with it. Sunlight became a dryer, wind became ventilation, and cold became storage. Fire became a smoking system, while salt became a preservation tool. Long before electricity, preservation already depended on understanding the environment. And that is how ancient people kept food fresh without refrigerators. If you enjoyed discovering how ancient civilizations solved problems without electricity, make sure to like this video and subscribe to the channel. Because here, we uncover the forgotten engineering, survival techniques, and incredible technologies that helped people survive long before the modern world. And in the next video, you might discover another ancient solution that still makes us wonder. How did they manage to do that back then?